Hello everyone. I will be starting with the session now. Dear authors and invited guests, welcome to technical session 10B. I am Dimahi Patel and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held on 4th April in Bangkok, and the virtual event is being held through Zoom for 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start with the presentations, I would like to introduce you all to the chair for the session. We have with us Dr. Kamran Dawood, sir. Sir is a senior research and development specialist at Astar Energy and Istanbul Technical University, Turkey. With over 6 years of experience, he has published more than 20 research articles during his doctoral studies and has research interests include leakage impedance characteristics of power transformers, transformer design and optimization, modeling and simulation of electrical machines, and computational electromagnetics. I welcome you, sir, to the session, and I request you to share any words you may have for the presenters today.
Thank you for inviting me as a chair. As Dimai already introduced me, I'm working in the Astro Energy as a senior research and development specialist. I have more than 90 publications right now. We can start our conference. At the end, I can give 1 or 2 minute ending presentation. We can start, Dimai madam.
Yes, sir. We also have with us Dr. Shalini Puri as a session chair. Dr. Shalini is an associate professor in the Department of Information Technology at Manipal University, Jaipur, India. With over 20 years of teaching experience and 11 years of research expertise, she specializes in machine learning, artificial intelligence, and image processing. Dr. Puri has published 31 research papers and actively participates in national FDP's workshops and training programs. Her research interests include machine learning, image processing, pattern recognition, and artificial intelligence. Welcome, ma'am, and I request you to share any words you may have for us here.
Thank you so much for the invitation, and you have already introduced me. Thank you so much, and all the best to all the participants for their research and the presentations. Thank you so much.
Thank you, ma'am. We'll be starting with the presentations now. Coming first up is Srihari Magar. Srihari, sir, are you here with us?
Yes.
Yes,
Am I
sir.
audible?
Please present your paper on comparative study of AI techniques in Parkinson's disease prognosis.
Yeah. Can you confirm am I audible?
Yes, sir. You are.
I'm sharing my screen. Is it visible?
Yes, sir. Your screen is visible to us.
Our research title is compared AI techniques in Parkinson's disease prognosis. And the authors are Ketan Desai, Chinmay Lothai, Srihari Magar, and Aditya Mane. So we are comparing the performance of machine learning and deep learning models for Parkinson's disease using speech and physiological biomarkers. So these are the contents and the overview of what we are going to present. We will start with a brief introduction, then motivation of our survey, objectives, methodology, and the overview of Parkinson's disease, what AI techniques are used or what data sources are there, and the comparative analysis of various models that were used for diagnosis of the Parkinson's disease. And we address the challenges and limitations of those papers as well. And finally, we will have conclusions and our question and answers. So introduction is that what is Parkinson's disease? So Parkinson's disease is a progressive neurodegenerative disorder which affects movement and coordination. It includes multiple symptoms like bradykinesia or dyskinesia or freezing of gait. So the movement, there are problems for the elderly people. It generally affects the elderly people. It commonly presents with the motor symptoms like tremors, rigidity, or bradykinesia, as well as some non-motor symptoms as well. So there is a variety of data sets that can be gathered from Parkinson's disease patients to in order to be detected that if they have Parkinson's disease or not. So early diagnosis of this disease is very crucial, which can be critical for improving patient outcomes. But also the methods are very, there are challenges in implementing those methods because there are multiple symptoms that can contribute to this disease. So our motivation to for this research paper is that it is a global health challenge and the clinical diagnosis is often very subjective. So early and accurate diagnosis is very crucial for accurate detection. So we can initiate the timely treatment and slow the disease progression. So there is a need of comprehensive DL models that utilize diverse data sources for early Parkinson disease detection. So we have if we have early Parkinson disease detection, then we can help those patients that are facing that problems in their older ages. So AI techniques offer objective, automated, and non-invasive tools assist in diagnosis, monitoring, and rehabilitation. So this survey aims that how AI can enhance the current clinical practices and address the limitations in the traditional diagnostics methods. So objectives are to provide a comprehensive view, then categorize the studies by the data type, DL models, and application areas. We are also comparing the performance of various deep learning models as well as some machine learning models as well to help with the diagnostic methods and clinical assessments. We are also identifying the challenges that needs to be addressed in order to make deep learning based detection a reality. So our methodology would be the requirement analysis that uh, let's define scope to focus on AI techniques that are used for Parkinson disease detection, then if or not, or monitoring or progression analysis. Then literature search, we used various sources to gather the research papers that we have studied, like Google Scholar, IEEE, etc. In compiling those papers on the recent timeline, the recent years papers were studied and the trends were analyzed that which models are preferred or what kind of techniques are relevant or state-of-the-art models are used while detecting the Parkinson disease. The filtration process that we used was that studies must focus on AI in Parkinson disease. Then it should prefer the real-world data sets gathered from the patients. Then innovative approaches like LSTMs or CNNs or state-of-the-art models should be used. Then peer-reviewed journals or repeatable preprint archives, we have referred there as well. And the clear evaluation metrics, which I have mentioned in papers, that is important part of as well. So the medical overview of Parkinson disease, that we have to consider various different points like what is the gait and posture. Gait is considering the movement of that patient. The freezing of gait, that person is not able to move sometimes. Bradykinesia refers to the slow movement of that person. Then tremor, dyskinesia, or there are multiple symptoms in Parkinson disease which makes it very challenging to detect it at early stage. So it is a chronic and progressive neurodegenerative disorder that affects motor functions due to loss of dopamine producing neurons in the brain. So it presents the motor symptoms like tremors, rigidity, bradykinesia, like we have seen in the previous diagram, and non-motor symptoms as well like cognitive decline, depression, and sleep disturbances. So data like EEG data can be really helpful to analyze the Parkinson disease patients. So the primary clinical diagnosis is there, which the papers have tried to enhance with the AI models, and it is based on patient history and neurological exams. So since there is no definitive laboratory test or biomarker for detecting Parkinson's disease, so this disease worsens over time and significantly impacts the patient's quality of life, requiring personalized treatment and monitoring. So these were the research papers timeline. There are only some papers that we have highlighted that what the trend is going, which direction in recent years. So first we have some machine learning algorithms and CNN network, convolution neural networks. Then we have some more enhanced algorithms or deep learning algorithms as we progress, like deep transfer learning based algorithm. And also that is combined with feature selection algorithms like heuristic feature selection or genetic algorithm. So that with feature selection and deep learning models, they have gained a better accuracy and better results with the Parkinson disease. So what are the various AI techniques that the papers have included in the while studying Parkinson's disease? Is that the CNNs are there, convolution neural networks, the long short-term memory networks, ResNet variants have been used, which have gained high accuracy in analyzing handwriting, speech, and EEG data. So handwriting, basically when their movement is not being controlled, we can analyze the handwriting of those patients and the image data can be analyzed. Feature extraction methods like MFCC or TQWT were used to represent biomedical signals effectively. Hybrid architectures were also used in some cases, which were SDC, GAN, or ResNet 50 together to enhance the classification performance through data augmentation. Optimization algorithms like genetic algorithms and gray wolf optimization are employed to fine-tune the model parameters and feature selection. So traditional machine learning were also used in some of the papers, which include the KNN, k-nearest neighbors, random forest algorithm, decision trees, logistic regression for structured dataset, which often have the numeric values and might be limited in some cases as well. So EEG-based detection also leverages the advanced spatial and frequency domain features like PSD and PLV for distinguishing Parkinson's from control groups. Handwritten pattern analysis can be passed to deep CNN models, which can detect whether the person has Parkinson's disease or not, which can help the medical professionals to analyze the patients further. So some of the data sets that researchers have used in their papers are the Oxford's Parkinson's disease detection datasets, which is consists of data from 31 people, 23 with Parkinson's disease and other were healthy. So there are 195 voice recordings from these individuals, and they have binary classification like 1 is for PD and 0 is for healthy. Then UCIML repository has another dataset for Parkinson's disease classification, which was from 188 patients, and ages were ranging from 33 to 87. Another UCI machine learning repository had Parkinson's speech dataset, which had sound recordings, and it was belonging to 20 Parkinson's disease patients and 20 healthy subjects. And the most widely and used is PPMI dataset, which is the standard Parkinson's progression markers initiative dataset, which is very valuable and large dataset to analyze Parkinson's disease patients. So there are various challenges and limitations that were addressed in the papers that we have studied. So complex deep learning architectures like deep hybrid or reinforcement learning models were not explored in some of the papers, which are limiting the model diversity. Most of studies are conducted on small scale, like we saw the data sets. There are handful of patients that were data were collected. So with that restricts the validation of the model generalization and scalability. High resolution data and large network models demand robust hardware, which may not be accessible in all research setups or even hospitals. Or if you want to deploy the real-time application for this, then the robust hardware needs to be there. Limited computational resources may hinder the real-time application, as I said. Variability in datasets and features can cause inconsistencies in model performance across different modalities. So
Excuse me,
there are
sir.
various
I would request you. I would request you to please end your presentation in the next minute, since your 9-minute
yeah.
mark has crossed.
So various algorithms that were used were CNN, and it has different components like we have seen. It has a convolutional layer, a filter, feature map, pooling layer, and fully connected layer, as we know. This is the working of CNN. Sparse autoencoders were also used, which has a neural network kind of architecture, which encodes the data, has the latent space representation and hidden units, which are activated at a time. So in comparison of existing systems, we have different data sets that were used by the papers and the accuracies that we have highlighted here. We can see that the deep CNN or deep LSTM models are getting high accuracies, and hybrid approaches are getting high accuracies as well. So these are the future directions for the research, that integration of multimodal data, implementation of deep learning architectures, real-time and edge deployment, large-scale validation and clinical trials are needed to enhance the future direction. So in conclusion, we have seen that CNN architectures with heuristic algorithms are significantly better performance with efficiency and performance as well. Deep CNN architectures are better than the transfer learning architectures in the Parkinson's MRI dataset. Heuristic algorithms for feature selection can reduce computational cost as well as improve accuracy in some cases. Further research on larger dataset and multiple patients or large broad data can be used, and multimodal analysis can significantly improve the reliability of the research. It's for the question and answers, please.
Kamran sir, any questions for him?
Yeah, I have. Thank you for the wonderful presentation, Shrihari. I have few questions. Your work is or presentation mainly have AI information. Can you tell me what is the main challenge in the early diagnosis of the Parkinson disease? Do you have any work on that, or you just have take from the other publication or like that?
We read multiple papers. The main challenge is that because it has a broad range of symptoms Parkinson disease has. So that is one of the main challenges, that we don't have any definitive parameters set on the detection of disease, that if you have this and this, then you have Parkinson's disease as. So that is one of the challenges. So we have to analyze various types of data from the patient, which is very challenging since hospitals don't collect broad data of the patients. It's some specific data can be collected.
I have one more question that you didn't tell about what is the importance of the artificial intelligence technique here to help the diagnosis. Okay, you have used the data, but what other, how it is beneficial as compared to the other early diagnosis? You say they are going to the clinical or something like that. What is the main advantage of artificial intelligence in this technique particularly?
So like different types of data sets can be passed, like image and stuff, as well as it can highlight what patients are susceptible to Parkinson's disease in their early stages. They may not have Parkinson's disease, since AI may not be accurate, but doctors can get an idea that this patient needs to be focused on, or they might need some more treatment, or needs
How
to
it is
be
different from the
focused.
clinical, like if we are doing a clinical test or something, how artificial intelligence is working here? Just for a question, how it is important to go for the artificial intelligence instead of the clinical test or like that?
Firstly, it would be time saving, maybe, and it would save significant amount of time for the doctors to analyze broad and large number of patients than to spend uh, meticulously spend time on each patient and analyze their data and say that, okay, this patient may have Parkinson's disease, or is likely to have a Parkinson's disease.
Thank you for your presentation again.
Yeah.
Thank you.
Thank you, sir. Have a great day ahead.
Shalini ma'am, any questions for him?
Yes, ma'am. I just want to add that you have compared a lot of models for this. So, were the differences in performance among AI techniques statistically significant? Did you perform any validation for this?
Yeah, we did perform some experiments that where like some models we compared, and we got that deep CNN models are performing better, or heuristic algorithms when are used with the deep learning models. While feature selection use heuristic algorithms and then combine with it deep learning models, they are getting better accuracies than a traditional model, which is not having robust feature selection methods, or just a traditional models. They are getting less accuracies.
Okay, so did you use any validation, any technique for the validation to check all these, because they may be having some different data sets also?
Yeah, different types of data sets are there. Like speech-based data sets, we can compare on basis that if multiple papers are based on speech-based data set, then if certain model can perform better or certain model doesn't. So we have that also considered uh, that we must have a standard ground to compare these results because different types of data sets are there. Some are images, some are MRI. So we did that as well.
Okay. And one more question. In general, in medical settings, model interpretability is also crucial. So, how interpretable are your AI models? And can they provide reasoning behind their predictions?
Currently, currently, these research works that we have studied, they might not provide interpretability, but tools like Lime analysis can be used on the image-based data set. So they can interpret the MRI images, for examples. We had tried that MRI data set as well. So on Lime analysis, it can analyze the results of the model and tell that what part is contributing to the class that we are predicting. So that is model interpretability is there as well.
Okay, that was from my side. Thank you.
Thank you so much.
Yeah, thank you.
Next, I would like to call Chaitanya Chaudhary. Chaitanya sir.
Yes, am I audible?
Yes, sir. Please present your paper on a novel multimodal approach to personalized mental health,
Yes.
body language, emotion, text, audio, and task analysis integration.
Okay. I am sharing my screen. Is it visible? Okay, so my research paper is titled A Novel Multimodal Approach to Personalized Mental Health, which would encompass several parameters like body language, facial emotion, text, audio, and task analysis integration. So I am Chaitanya Chaudhary and I am affiliated to the JSPM Sahasisha College of Engineering, which is situated in Pune, India. So other authors for this paper include Gayatri Asadkar, Rutuja Khedkar, Shardul Deshpande, and Yogesh Deshmukh. So as we all know that mental health issues, they are a global issue right now, and they have affected over 970 million people in year 2020 alone. And COVID-19 it caused a 25% surge in cases of anxiety and severe depression. So challenges in diagnosis, they are influenced by socio-economic inequality, systematic barriers, and discrimination. Also, there is a stigma attached to the fact that people visit mental health professionals. Also, there is a huge shortage in number of mental health professionals, which contribute to the underdiagnosis and delay in treatment. Also, comorbid conditions make accurate diagnosis difficult. The role of AI and machine learning is very, very important here because there's a huge shortage of mental health professionals and they can be very useful in predicting outcomes, for identifying correlations, and also for analyzing the large data sets. Now, there are several challenges which occur in the traditional method which are used for identifying the mental health diseases. So, mental health diagnoses are often based on subjective self reports and clinical assessments, which can lead to inaccuracies. Also, some of the other limitations they include that text-based sentiment analysis alone misses non-verbal emotional cues. That's why audio and visual cues they can also come handy. Current methods they lack a holistic multimodal approach that integrates all these parameters like text, audio, body language, and facial expressions. So there is a need for a multimodal approach in order to solve these mental health issues. So multimodal sentimental analysis would combine text, audio, visual data to provide a comprehensive understanding of the emotional states. Like PLD, which is point light display, it can be used to identify the body language movements in order to predict the uh, mental health state of a particular patient. So this is our proposed model flowchart. So we would collect information in form of visual data, textual data, audio data, and body language data. Now we would perform analysis separately on each of this data that we have collected, and then we would combine it. Okay, so for facial data, we would perform CNN algorithms. For textual data, tokenization and normalization techniques would be conducted, after which we can perform bag of words, algorithm like bag of words or BERT, which has proven to be like very efficient these days. Also, for audio data, feature extraction technique can be used. For body language method, as I said earlier, PLD or point light display method can be used. So after that, we would integrate all these models, and then this would help us to generate reports, dashboards, and mental health recommendations. So for textual data, we would use NLP techniques like BERT and word to vector. For audio analysis, we would use vocatory algorithm, which would analyze speech features, speech intensity, to detect emotions such as anger or sadness. For visual analysis, PLD or point light display, and OpenPose, which is actually a computer vision based algorithm library, it can be used to track body movements, providing insights into body language. For facial expression detection, we would use CNN, RNN, and SVMs to assess the facial expression. So using a combination of all three algorithms would help us to maximize the overall accuracy. So we have also taken into consideration the fact that people or patients can be from different parts of the world. That's why it becomes really important to like include data sets which would uh, belong to different culture, people of different culture. That's why we would incorporate diverse data sets like Japanese emotion data set and Indian sign language data set to enhance the accuracy. So our proposed model also focuses on the fact that early detection should be done, and we should be dynamically monitoring the results. So that's why the model detects subtle emotions, shifts in text, speech, body language, and facial expressions, providing early indications of mental health issues. So, for example, increased negative sentiment in text, shifts in vocal tone, or posture changes can signal conditions like bipolar disorder or PTSD. Timely intervention is also very important. That's why this real-time monitoring allows for early intervention and personalized treatment and adjustment for conditions like schizophrenia and mood disorders. Now, iterative feedback loop also has been included in this overall model because it would help us to like continuously provide feedback loops, ensuring that mental health professionals they verify and adjust the prediction. So for task-based analysis is also part of this model. This model analyzes patient adherence to the prescribed activities, ensuring that treatment plans are followed. For impact evaluation, it tracks how these activities influence emotional states and adjusts treatment plans for optimal care. Continuous monitoring, regular tracking of all modalities ensures that any adverse effects are promptly detected. For personalized treatment, proactive monitoring allows for real-time adjustments, ensuring that care is continuously tailored to the patient's needs and well-being. So it is because we would be using all this sensitive data, it really becomes necessary for us to like have some ethical considerations as well. That's why privacy and consent, data protection, cultural awareness, human oversight, and all these things become very, very important. So that's why this model emphasizes on patient privacy and informed consent. We would use encryption and anonymization to safeguard sensitive data. This is also designed to be culturally sensitive, ensuring that it provides unbiased analysis across diverse population. Also, talking about the ongoing monitoring, the system ensures that all the interventions align with patients' preferences, ensuring patient-centered care. Now, talking about the methodology that we would use. So, for text-based sentimental analysis, technologies like Python, TensorFlow, PyTorch, NLTK, Spacey, BERT, and Word2Vector, Glow, all these algorithms can be used. We would use web scraping and APIs to gather the online data. then tokenize and lemmatize with NLTK and SPACY, apply word to vector and glow for content aware representations, and then classify the sentiments for text based sentiment analysis. For auditory sentiment analysis, we can use algorithms like Vocaturi, Python, and Keras, and we can then extract MFCCs using the Librosa algorithm. Then we can train RNNs for emotion detection and combine vocal cues with text analysis to enhance emotional understanding. For behavior analysis through the body language, we would use technologies like OpenPose, PoseNet, and for pose estimation, we can use extract joint coordinates from the video. So for facial emotion detection, we can use technologies like TensorFlow, Keras, OpenCV, CNN. For facial extraction, we would analyze facial features using CNN, apply SVM or CNN for emotion classification. So computer vision would also play a very important role here, and it would involve technologies like YOLO and faster RCNN for object detection, track facial expressions, gestures, and movements. And talking about action recognition, we would analyze actions using temporal network, objective being enhancing visual data interpretation for mental health assessments. So if for like detecting the issues earlier, we would aggregate multimodal data for early detection of mental health. We would use anomaly detection technique like isolation forest and autoencoders, identify early signs of disorders like depression, PTSD, and anxiety. Also, because we would be having all this data, we would have to like dynamically track it. That's why we would use technologies like Apache, Kafka, Flink, and Kinesis, and then we would stream this multimodal data for ongoing analysis. So after all this process is done, we would like perform task-based analysis, and it would involve monitoring the adherence to the therapeutic activities, be it movement, exercise, or whatever thing. And then we would ensure patients following treatment plans and adjust them based on the real-time feedback. Patient safety is crucial for us. That's why we would use anomaly detection to monitor negative effects from the intervention so that we can tell them to approach a mental health professional if needed. So these are all the references that we followed. We referred to work of 22 different research papers. So thank you for patiently listening to me. I'm open to answering your questions.
Thank you for the presentation, Chaitanya. I have a few questions. First of all, you have hello. Is my voice clear?
Yes, yes, it is clear now.
Huh? You have told you that there was a 25% increase surge in the anxiety and depression after the corona. But how about the trend? How it is going right now? Furthermore, you didn't compare or consider the age factor of the person. So, do you think that it affect the results as well?
Okay, after COVID-19, there was a huge surge in cases of mental health cases, but
Mhm.
I would say that that kind of surge haven't happened now, but still the cases they are significant because of the use of social media and also warlike situation in some places. The global impact that it has is still significant. That's why it becomes really necessary to focus on mental health issues, and also because there is like a stigma attached to the fact that people visit this mental health professionals. That's why it becomes really important for us to like make the process at as transparent and as easy as we can for the people.
What about the age factor?
Age factor, yeah, that
Mhm.
that's why like we have included this diverse data sets, be it uh, Japanese data set or Indian data sets, and people of different age, like they show some different characteristics. That's why we would have to train our model accordingly. That's why we would have to like provide more and more data as we can.
You have combined different parameters. What about taking two parameters, then three? Is it affect the efficiency of the different parameter? Do you think like that?
Yes, it does, because some of the symptoms they cannot be captured by only one model, and we
Mhm.
because we refer to all this work of 22 different uh, research papers, work which were displayed in these 22 different research papers, we found that some of the modalities they are not able to like capture all the symptoms, and multimodal model is able to capture all the symptoms. It is much more accurate than as compared to uh, just like one single modality results.
Mhm. Will it improve the mental health, or it just diagnose or see that how mental health is working like that? Will it improve or
uh,
just take
yeah,
see the
so
results?
it would like diagnose. It will also diagnose as well, because it also has a task-based analysis, and
Mhm.
because we know that AI cannot handle everything on its own, that's why we have also included the fact that if a person is like having is going through some serious thing, then he can approach a mental health professional, and we would also give him some tasks that he can complete, so his mental health conditions would improve,
Thank you for
which
the
would be
answer.
monitored as well. Yes, thank
Thank you.
you.
Shalini ma'am, any questions?
Yes. I want to ask, like, how does your model account for cultural or situational context in interpreting the body language or speech?
Yeah, that's why we have like integrated several cultural data sets. So this helps us to like make sure that our model is comprehensive.
So what were the size of those data sets? Can you please tell?
For Japanese, it was about 1 lakh. For the
Okay.
Indian sign language, I have to check it. But
Okay.
all these models that I have used are they were pretty standard. So they have multiple data, they were pretty large.
Okay.
Yes, thank you.
Given the one more question is like, given the sensitive nature of mental health data, what measures did you take to ensure data privacy, especially with video or audio components?
Yeah, that's why encryption and anonymization has been used, so that this data is not read by anyone else, and this data is only the access of this data is only given to the AI or the model which would be like used to predict the outcomes.
Any special algorithm for such data encryption, etc.?
The standard ones, standard
Okay.
cryptography based algorithms.
Okay. My one more question is that can your approach be scaled to large populations, such as in schools or workplaces, or does it require personalized calibration?
No, this one can be scaled to a larger population as well, because the our model is like very comprehensive. We have considered every fact. We also used the method of feedback loop, so that our model only improves over time.
Okay. Thank you.
Yes, thank you. Have a nice day.
Okay, thank you so much. Now, next, I would like to call Prajwal Lonari. Prajwal sir, please present your paper on a survey on arrhythmia disease detection using deep learning techniques.
Okay. Is my screen visible to you?
Yes, sir.
So, hello everyone. So, our paper number is 207, and our authors are Dr. Ketan Desle. I am Prajwal Lonari along with co-authors Somova, Nitin Pandit, and Ritesh Parate, presenting our paper on a survey on arrhythmia disease detection using deep learning algorithms. So, this is our outline for today's presentation. So, starting with introduction. So basically, arrhythmia is an irregularity of heartbeat that causes an abnormality in the heart rhythm. So basically, it is one of the most significant cardiac health issue globally, which often leads to the life-threatening situations. So arrhythmia entails a broad spectrum of disorders of heart rate and rhythm abnormalities. So our studies aims to contribute to the automated arrhythmia disease detection and classification, because the in the hospitals the doctors takes the ECG signals, and then based on it they predict the whether it is arrhythmia and which type of arrhythmia. So we are doing research to create a automatic heartbeat classification method. So the objectives of this research is to determine the appropriate technique for detection of the arrhythmia, and to find an efficient method that would reduce the time, because time is the major factor in our research. So we are trying to reduce the time for the detection and classification. Third one is to design and develop an automated system. As I earlier mentioned, that we need to work on the automatic system for the detection of the arrhythmia. And lastly, to improve the accuracy, which is the major factor, and reducing the computational time. So the motivation behind this research is to, as arrhythmia is a common and dangerous, we all know that there are multiple large number of population which are suffering through the heart problems and heart failure. Heart strokes are one of them. So arrhythmia is most common and dangerous. Second one is traditional methods have problems. So doctors check ECG manually, which takes time and lead to the mistakes. And sometimes there will be different types of arrhythmia. So we are not able to detect all of these. And there are some rare conditions also. Third one is the AI makes the diagnosis faster. So we all know that there are different AI machine learning, deep learning techniques which will help the doctors, which will save our time and which are more accurate and reliable. We can validate it, test it, and validate, which will improve our accuracy and reliability on the detection and classification. And last one is personalized treatment. So each one of us can get a personalized healthcare system based on which we can get our different types of arrhythmia classifications. So the project requirements for our research is, for first one is software requirements. So for which we have used the Python language and deep learning frameworks like TensorFlow, PyTorch, libraries like Pandas, NumPy, Matplotlib for the visualizations purpose. And we have used the Google Colab as our platform. And talking about the hardware requirements, we have used the Intel Core i5, AMD Ryzen 5 with a RAM of 8 GB and storage of 5 GB free space with dedicated GPU and TPU present in the Google Colab. So moving forward to the dataset design, we have used the MIT-BIH arrhythmia dataset, which is a globally used for the arrhythmia detection, which is the ECG dataset. So it was created by the MIT Laboratory for Computational Physiology and Beth Israel Hospital in Boston. So our source is database with the ECG recordings with attributes and features of along 188 and entries along 1,09,446, which contains 87 plus thousand for training and around 22,000 for testing. And here we are classifying basically four types of arrhythmias: the normal beats and uh, others are four R's abnormal arrhythmia beats. First one is premature ventricular contraction, atrial premature beat, ventricular escape beat, supraventricular premature beat. So uh, based upon the ECG recordings, the different types of arrhythmia occurs, and there are different there are multiple types of arrhythmia. So we are basically focusing on these four. So talking about literature survey, the papers we have referred. First one is classifying the cardiac arrhythmia from ECG signals using deep convolutional model. So it gains the accuracy of 98.5. Here the author used the one-dimensional CNN model. Second one is cardiac abnormalities classification model using improved deep learning approach, where the author got the 98% accuracy. Here also they have used the custom CNN. Third one is ECG stitching scheme for driver arrhythmia classification based on deep learning. Here they got something less accuracy, about 96.39. Fourth one is the modified deep learning framework for arrhythmia disease detection in medical imaging using ECG signals. So here they got 98.7% accuracy. And last one is the very large scale integration chip design for abnormal heartbeat detection using a data shifting neural network, which is a DSNN. So here they got 97.17 accuracy. So this is the comparative study of all the five papers. So we have also used the MIT batch dataset, and here we have taken the authors who have used the MIT batch dataset. Though, so the highest accuracy we got here is 98.7%. So we have also implemented the CNN. So CNN basically a deep learning algorithm where we have the input layer, output layer, and hidden layers. So here we have used the pre-processing techniques like resampling the data set, applying the filters, where we have used the Butterworth filter. So talking about the CNN, where this is the mathematical representation of the neuron used in the CNN. Y equal to fjx equal to phi wj, comma x plus bj, where fi is the function, phi is the activation function, wj is the connecting weights, and bj is the neuron bias. Here we can see that standard node. So first layer we have used the convolutional layer. For this we have used this mathematical formulation. So it is basically used for learning the extracting the features from the input data. Second one is max pooling layer. Basically it is used for the feature mapping, reducing the high dimensionality to low dimensionality. And last one is fully connected layer, which is enabling the model to combine feature extracted by the convolutional and max pooling layers. So this is the CNN architecture we have used. We have total 7 layers, total 11 layers. First one is input and last one is output layer, and corresponding 7 convolutional max and fully connected layers. So this is the structure we have used. So we have first one is input layer, then we have convolutional max pooling, alternate layers, and lastly fully connected and output layers. So for this research, we got the accuracy up to for validation. We have used the different types of the trench test split: 75, 25, 80, 20, 85, 15, and 90, 10. So we got the highest accuracy for the, here we can see 98.99 for 90, 10. So there are different parameters. Confusion metrics are also generated. So we have calculated the accuracy, F1 score, precision, and recall, and we are getting the highest uh, result for this test split. So talking about the result interpretations, so
Excuse me, sir.
okay.
I apologize for interruption, but this is a gentle reminder that you've crossed a 9-minute mark, and I would request you to end your presentation within the next minute. Thank you.
Okay. So here we got the highest accuracy for 90-10% test split. And talking about the future scope of the, we are using the advanced learning, transfer learning methodologies in it. We are using the ResNet for that, and where we cross the around 99% accuracy, and where we can use the generative adversarial networks to create the realistic synthetic ECG signals to expand our data set, as there are different types of arrhythmia. We cannot get the sometimes we cannot get the recordings from that. Third one is that we can create the deep learning variables. The tech giants like Apple also working on these smart watches for the arrhythmia detection. And we can also use the model compression, means we can use the techniques like distillation, quantization enable to learn the efficiently our model. And we can also use the multimodal data fusion, combining patient health records with PPG and echocardiogram signals, which improves our diagnostic accuracy. So basically we are working on the ResNet model for improving our accuracy, which is our future scope. So this is the end of our presentation. Thank you. So if anyone has any question, we are free to answer.
Thank you for your presentation. Actually, you have an accuracy of more than 98%, almost all of the model.
Yes.
What about the time consumption for each of the model? Is it similar, like a 1 or 2% change, or there's a big difference?
There is no big difference, so that's why we have not considered. So that is our future scope. We are working on the ResNet model, and for validation we are using the different test split. That's what we are working. So basically it is our first paper we are presenting. So here we have taken the CNN as our base model, and we are trying to customize our CNN using the transfer learning, where we can customize our layers in the CNN model. So that's what we are working on, because we are doing to reduce the time complexity. That's what's our future scope. So
Thank you for your answer.
yes.
Yes, I want to ask, do the surveyed models mostly work with single lead ECGs or multi-lead systems from hospitals?
So it can work with the multi-lead also. So depending upon the model complexity and the model which are we using, here we have used the single lead, But as I have mentioned that we have also generated the resonate models which will can work on the multimodal ECG signals also. So that's what it is. A future, it is a broad spectrum. Here we have used the classification of only 4 bits. So that is the main challenge in front of us, that we need to classify the more types of arrhythmia, because there are some rare types of arrhythmias also. So for that purpose we are using it. So it is our we are basically working on it. Yes.
Okay. Thank you.
Yes, thank you.
Thank you so much. Now, next, I would like to call Ali Naji Salami. Ali, sir, to please present your paper on advances in emotion detection and facial expression recognition, a comprehensive review of machine learning and deep learning approaches.
Hello, everyone. It is a pleasure to be here today at this estimate conference. My name is Ali Naji Salami. I am a research scholar at Mahatma Gandhi University, India. In this presentation, I will be discussing my paper titled Advances in Emotion Detection and Facial Expression Recognition, a comprehensive review of machine learning and deep learning approach, which is a systematic literature review on the advancement, challenge, and future direction in facial emotion recognition using AI techniques. I look forward to sharing my insight with you and engaging in fruitful discussion. Thank you for your time, and I hope you find this presentation valuable. Introduction. Emotion detection and facial expression recognition have emerged as a critical aspects of human-computer interaction as a technology strive to understand the human feeling in different fields such as health, security, sales, and teaching. There are different ways of identifying emotion, but most promising approach is facial expression recognition, where a facial expression represents up to 55% of emotion information. Typically, FER performance is evaluated using measures like accuracy, precision, and recall. However, problems like real-time detection and datasets shift remain a barrier to achieving a further advancement in FER systems. There are 3 approach or techniques used in facial recognition system, which are traditional machine learning techniques, deep learning approach, and hybrid approach. In machine learning, there are 3 key steps. Pre-processing is the first step in handling the image to reduce noise, enhance, normalize the image. The second step is a feature extraction, involve obtaining important facial features. And the last step in the classification of emotion. In traditional machine learning technique, feature extraction is done manually. So like methods like BCA, LBB are usually used. After feature are extracted, then classification methods like SBM, KNN, decision tree are employed to classify emotion. This approach suffers from some challenge and limitation, such as manual feature extraction. Although these methods rely on expert design features, they are slow and error-prone. Data sets variability. The system decreases in performance when some factors that are not under the control of the system come into play, like change in lighting, facial rotation, or wearing accessories like glasses or masks. And third one is real-time processing, as these methods make use of handcraft features. Such approaches are slower for use in real-time environment. This figure showing the traditional machine learning technique from input image processing, feature extraction, classification. Now we will go to the deep learning approach. Emotion recognition has a benefit significantly from deep learning, especially CNN, since they eliminate the need for manual extraction of feature from image, which make them suitable for handling a large data set in facial expression. Some of this algorithm like CNN achieve fully automated facial feature learning. RNN is suitable for emotion recognition based on video sequences. GAN are used to generate a new data traits. Although this approach offers more benefits than machine learning, they also suffer from some challenge and limitation like real-time performance. The high computational requirement of deep learning model make them impractical for real-time operations. Generalization on new data sets data quality. The accuracy of deep learning models is determined by the quality and variety of training data used. Hybrid approach. By combining the best of machine learning and deep learning, hybrid models offer a higher accuracy rate in recognizing human emotion. Therefore, they are highly effective at identifying various dynamic facial expression and other complex emotion attributes. For example, by LSTM plus deep neural network enhance multimodal emotion recognition, especially for sequential data such as video. Multi-feature fusion can also be used using visual, audio, and even physical features to increase the probability of correct emotion classification. This approach suffers from challenge and limitation as well, such as complexity. In most cases, hybrid models are developed with more layers and therefore are less efficient and take more time to training as well as inference. Integrating information from different model and modalities can complicate the combination steps when dealing with diverse data source. This figure showing the face emotion detection approach, machine learning, traditional, deep learning, and hybrid model. Now we will go to data sets. Common data set, the FER model performance largely depend on the dataset and its properties. There are many datasets currently available for facial emotion detection, but in this paper, we focus on the most popular databases like FER 2013, EffectNet, CK+, FER 39,000. The challenge in datasets are most FER datasets include a sample with low ethics and age diversity, which make it possible to train models that are suboptimal for less represented group. Now we will explain performance evaluation by some of the literature. Thailand developed a real-time facial emotion recognition model for children with autism using deep CNN, autoencoder, and pre-training model with 95% accuracy. Mohammed Ilyas study on facial expression recognition used RESNet 50 as a backbone model. Several databases were used for training and evaluation. The model gave a higher accuracy on the KDEF datasets with 97%. BJOM present emotion recognition approach for e-learning environment employ the Vilo-Jones algorithm for face detection, LBB for feature extraction, and fuzzy neural network for classification. The system achieved a high prediction accuracy of 91%. This table shows the literature, all the literature reviewed in this paper, along with technique and databases used and the result obtained. Here, many of authors used the CK plus and GAFEFE datasets with this technique and the results obtained. The challenge in emotion detection and FER, although the extension of big data and transfer learning have also enhanced system performance on large and multi-class datasets, there are still key factors that embed the efficiency and general adoption of emotion recognition systems. Some of this challenge like generalization and robustness. Model generalization is one of the biggest problem facing FER systems. Despite performing very accurately in test environment, such model fail to generalize to the real domain. Real-time processing. Real-time emotion recognition is valuable but face challenges such as latency, high computation requirement, and power consuming, especially on mobile devices. Ethical concerns and bias. FER raises ethical concerns about bias, privacy, and transparency. Bias occurred due to demographic imbalance in datasets and the use of FER technology in surveillance also poses a threat to human privacy. A future work and conclusion. So to overcome this challenge in the future, further research in FER should continue by trying to mitigate the problems faced in current methods by using a new approach that combine the benefits of traditional machine learning, classification, and deep architecture in improving generalization and accuracy. The use of multimodal data will enhance emotion detection, especially in natural complex environment and situation with occlusion or ambiguous facial expression. Moreover, the increasing demand for applications that require real-time processing requires the development of less complex models suitable for use on smartphone and other embedded system. Edge AI and fog computing can contribute to minimize latency and facilitate real-time emotion recognition on scale. Establishing law regarding individual privacy and data collection would reduce ethical concerns. Overcoming this challenge in the future will make FER system more reliable, optimized, and less susceptible to ethical issues. This reference is used in paper, and thank you.
Thank you for the presentation, Ali. I have just one question.
Yes.
Actually, every method has a more than 95% accuracy. What do you think about which technology have improved the accuracy of emotion and facial expression recognition system? As if you want to tell one system, which will be?
Pardon, sir, I don't understand. Can you repeat the question?
Yeah, I can repeat it. As I see the efficiency of your models, all of them was, or other works was more than 90%, as we saw
Yes.
it. My question is, which technologies have improved the efficiency or accuracy of emotions and facial expression system? So if you tell one name, what it will be?
Actually, I use in my paper the current research and papers. They use so many methods used like RESNet, using transfer learning and pre-training model. Actually, this pre-training model and transfer learning is very effective for emotion recognition. That's why is there some accuracy up to 95.
Mm-hmm. Thank you for your answer. Thank you.
Okay.
Ma'am, any questions?
Yes. Yes, Ali, I want to ask, what are the main limitations of your work?
Actually, the limitation, the real-time performance, because you know, emotion recognition used in a classroom sometime or for healthcare. That's why the main problem in real-time detection for emotion. And another limitation is a privacy for because sometimes the person don't know they will detect emotion for them, and this threat for them privacy.
Okay, thank you.
You're welcome.
Thank you, sir.
Okay, thank you for fine, thank you.
Yes, sir.
Have
Now,
a nice
next, I
day.
would like to call Kanishka Vishwasrao to present a study on advancing women's safety through smartwatch wearable integration with heart rate and oxygen monitoring. Kanishka, ma'am?
Hello, I'll just share my screen.
Yes, ma'am.
Yeah, is my screen visible?
Yes, ma'am, we can see it.
Okay. So good afternoon, everyone. My name is Kanishka Vishwasrao. Yeah. So good afternoon, everyone. My name is Kanishka Vishwasrao. And today I'll be presenting my paper or presentation on advancing women's safety through smartwatch integration with heart rate and oxygen monitoring. So this is my content: introduction, literature review, proposed model, architecture overview, methodology, result, future scope, and conclusion. So, introduction. Women's safety is a real-world problem everywhere around the world. And by the influence of the existing technology, we aim to develop a project which is a fast and reliable solution to help women during emergency. So in this project, we aim to integrate smartwatch technology run with a mobile application with real-time health monitoring. The system detects abnormal heart rate and oxygen levels during emergency alerts. The aim is to provide an accessible, effective, and technology-driven safety solution. Smartwatch-based safety mechanism. Uh, the application is connected to smartwatches to track heart rate and oxygen saturation levels. The algorithm used here is the isolation forest algorithm, which is a machine learning algorithm to identify irregularities in the user's physiological data. So here, if there is an unexpected increase in the heart rate or say the oxygen levels or if any unusual trend is seen, it activates alerts. So this proactive capability guarantees prompt reactions and assistance. Consequently, the app offers ongoing monitoring, immediate notifications, and health management, establishing itself as a reliable tool. Literature review. So, firstly, with existing applications, we have some features such as real-time location tracking, SOS alerts, and emergency SMS or calls are standard across most safety applications. Then some applications have advanced capabilities such as voice commands, live streaming, ambient audio recording, and automatic routing via GPS and SMS. Also, integration with wearable technology, as we are attempting to do here. The smartwatches and pendants that track health metrics such as heart rate, SpO2, or your stress levels and send alerts during anomalies. AI and machine learning use. AI models identify stress levels and detect anomalies in real time. So the role of wearable technology in women's safety. The smart wearable technology provides personalized insights by monitoring metrics such as oxygen levels, stress, calorie burn, heart rate, sleep, and steps using advanced sensors. In emergencies, the device detects abnormal readings and notifies a guardian with the user's location, ensuring prompt response to improve personalized health. Detecting future occurrences and identifying anomalies in the recorded data, primary goals of wearable device data analysis. This is done by training the model with recorded data and testing the model's performance with new data. So this is the proposed model. There is a user which has to log in or sign in to the mobile application. The functionalities are the Rebellion SOS button, GPS tracking, emergency contacts, which is stored in a database, and smartwatch integration, which monitors your O2 and heart rate levels. If there is a sudden change or if there are alarming levels, there is an alert sent to emergency contacts. Also, if the user wants, there is a manual SOS button too, which the user can press in terms of emergency. Now, for example, this is an example for data set. So we consider three values here, three E's for heart rate and oxygen saturation. And we use a min-max scaling formula here, where X is your raw feature value, which is either your heart rate or your oxygen saturation value. Min is your minimum value of the data set, and X max is the maximum value of the data set. And X dash is the normalized value in the range 0 to 1. So here we have two more terms called as path length formula and harmonic number formula. The path length it gives the distance between your your measured value, what your detected value is, and the abnormal value is. And harmonic number formula is used to compute the average path length in isolation forest to determine the anomaly score. The flowchart here, just zoom in. So you start, this is a basic structure of how the application will work. It was login, sign in, there's a OTP verification. If the access denied, you need to retry OTP. Access is granted, then you need to give permissions to store user data, add emergency contacts, store information in database, give permissions. So the main features include here are location sharing, SOS button, emergency calls, and smartphone connectivity. So location sharing, for this also we need to grant permission with which we can share location and send alerts. For SOS button, once the SOS button is pressed, we send if the application sends an SMS to contacts, emergency calls, and again for smartwatch connectivity, it will monitor heart rate and oxygen levels. And if they are below threshold values or they are abnormal values, it will send an alert. Also for architecture overview, secure user authentication, real-time tracking with Google Maps, smartwatch health monitoring, and anomaly detection with machine learning. Methodology also consists of the SOS button functionality, where users with a single tap can send an emergency alert, real-time location tracking, which uses GPS and mobile networks to track the user's location, quick and secure sign-in, and instant alerts and notifications. Result. The application offers an integrated solution combining real-time tracking, health monitoring, and emergency alert features. SOS and location-based alerts ensure faster communication with emergency contacts or services. Smartwatch compatibility helps detect unconsciousness or distress through heart rate and SpO2 monitoring. Machine learning models help minimize false alerts, making the system more reliable. Future scope. What we can do in the future is we can ensure cross-platform availability to ensure seamless functionality across Android, iOS, and wearable OS platforms. Offline emergency features using SMS-based communication in the absence of internet, and enhanced voice-based activation and gesture-based triggers for faster discrete SOS activation. Conclusion. Functionality such as real-time location tracking, SOS alerts, enhance response time, fostering a proactive approach to personal safety. The integration of smartwatch technology further elevates the application's utility. It offers an extra layer of protection by tracking heart rate and oxygen saturation. Health monitoring and a safety device work together to guarantee that assistance is provided quickly, even in emergency situations. With future development aimed at cross-platform availability and handling network outages, the app stands as a powerful tool for women, providing enhanced security in both everyday and emergency situations. Thank you.
Any questions, sir?
Yeah, I have one question. Why there's a name woman in that manuscript name, or I can say in the title? What is the difference between the results of the man, male, or child, or a woman? There was no discussion about that as well.
Okay, sir. So basically, according to whatever is happening, if we see today's world or condition, then women, uh, there are many cases where, say, women are traveling in the night or they have to travel alone. There are more cases where women are getting, where women are not safe in today's world. So we have tried to we have tried to research on the fact that it is specifically women oriented.
Generally, male have a more heart problem. That's why that was my question. Is it applicable to the male as well?
Yes, sir, it will be applicable. Uh, Algorithms and smartwatch connectivity will be applicable to men as well.
And how smartwatch send the data to the system or like that? There was no discussion about that as well.
Okay, so actually we haven't included in the PPT. We are still working on it. But we have thought that maybe whenever we connect a smartwatch to our mobile application, a smartwatch always measures how much sleep we have got or what is our heart rate, what is our pulse rate. And this information is stored in our phones whenever we connect the smartwatch to our phones. So if we connect, so if there's a connection between a smartwatch and our phones, the application can get data from the sm- smartwatch app and then work on the data.
So we need an active internet, I think so, isn't it?
Sorry?
We need an active
Yes,
internet to
internet.
send it.
Yes.
Okay,
Yeah, we
thank you
need
for your
internet.
presentation again. Thank you for your answers as well.
Okay, thank you.
Okay.
Ma'am, any questions?
Yes. I want to ask, what were the biggest challenges in integrating health data with smartphone platforms for safety applications? Something like latency, battery consumption, or data accuracy?
Yes. So, ma'am, the biggest issue we face is network connectivity because sometimes if women are in no network zones, then it will be a major task to uh, communicate with the application.
Okay, another question is, how is an emergency signal triggered? Automatically based on thresholds or manually by the user?
So there are two ways, either a manual SOS button or the smartwatch where it detects your heart levels or oxygen levels. Now, for us normal human beings, we have a normal heart rate or a normal oxygen level. However, if these values are there is a sudden spike, not a gradual or not over a period of time, but there's a sudden spike or a sudden change then it results, suppose a person is unconscious. In that case, there is a sudden change in the heart rate and oxygen levels too. So that is an example of a case where an emergency alert will be triggered.
And another question is, how do you address concerns that such systems might be misused for surveillance, especially in restrictive environments?
About the misuse, ma'am, I really haven't thought about it.
My question is, how will you address the concerns like such systems may be misused for surveillance, something like that, especially in the restrictive environments?
Then maybe we can ensure more security or more authentication measures are carried out in the application.
Yeah, you can put this issue in the in your future work, right?
Yes. Yes,
Yeah,
ma'am.
thank you.
Thank you, ma'am.
Thank you so much. Next, I would like to call Samir NMD. Samir sir, are you here with us? I repeat, Samir sir, or is any of the co-author of this paper present right now? All right, we'll move to the next one. I would request Rijul Tandon to present their study on energy delay aware task offloading and UAV integrated mobile edge computing using RL. Rijul
Hi.
sir?
Yeah, sure.
Yes, sir.
Okay, so what we have done is our paper investigates the application of reinforcement learning techniques in task offloading. Task offloading is basically when a device gives one of its tasks to be executed to some other server.
Excuse me,
Uh,
sir. I'm sorry for interruption, but are you screen sharing?
yeah, I sent the request to share my screen. I'll send it again.
Can you please try again?
Is it visible now?
Yes, sir. We can see your screen now.
Okay, so I'll start again. Okay, so this paper investigates the application of reinforcement learning in task offloading. So offloading is when a device sends one of its tasks to some other server to be executed. And in our case, offloading is being done in dynamic edge computing environment. Edge computing is basically an additional layer in between the mobile device and cloud. Due to the limitations of cloud discussed further, led to the development of edge computing layer. So our primary objective is to minimize delay and energy consumed while offloading tasks and locally executing them. So coming to the next slide. So there were some challenges in cloud computing when we talk about task offloading and uh, like keeping a balance between energy consumed and the delay. So the demand for resource intensive applications like virtual reality and augmented reality is increasing. That motivates devices to offload the tasks to cloud. And as we know, cloud basically when used for storage and also like servers like Google Colab we use, they have high latency due to the long distance. So it is less suitable for real-time and delay-sensitive applications. So the solution for it was to develop edge computing layer. Edge computing layer make basically the edge server is far nearer than the parent cloud, so it takes less time and less energy. Um, Also, with this development, we move to UAVs or drones. UAVs with the motivation of the growth of chip industries allow UAVs to be comparatively act as comparatively powerful servers as compared to mobile devices and small IoT devices. They are still not as powerful as the cloud servers, but they are as compared to mobile devices, they are much powerful. So UAVs, why we are motivating UAVs to be as servers. They are dynamic, and it now uh, removes the need to establish edge servers at every point needed, as UAVs can be easily moved to different positions as per need. Uh, Again, motivating about the use of UAVs. They Substantial computational capabilities allows them to fairly easy work with the task that mobile devices are facing difficulties to execute. UAVs are dynamic. Uh, they are very flexible and provides adaptive solution for fixed edge infrastructure. Uh, Computational capabilities can be provided on demand in disaster-stricken areas or in regional areas where servers and infrastructure is not as developed. Additional UAV capabilities, we have also witnessed UAVs being fitted with powerful water spray guns for cleaning large skyscrapers and in firefighting operations. UAVs are being highly used for surveillance when equipped with high resolution cameras. So with all this environment, edge computing, UAVs, and task offloading, now the problem was which task should be offloaded by the mobile device and which should be executed locally. So the situation is very dynamic. The bandwidth can change in disaster-stricken areas, and the UAVs are mobile, so their positions will change. Mostly the IoT devices are mobile with their positions. So to handle all this dynamic infrastructure, reinforcement learning is a very efficient and adaptive solution. Unlike deep learning and machine learning models, which cannot learn on the fly and require extensive training before being used, reinforcement learning, on the contrary, can learn on the fly. So in RL environment, we have the agent, which particularly explores what is an optimal action by taking an action, getting a reward for it. If it gets a positive reward, basically it will learn that something I did was good. So with this simple infrastructure, it explores and moves to finally learn about the environment and execute optimal actions. In our framework, mobile devices or IoT devices are acting as reinforcement learning agents. They will take an action to offload the task to UAV, and they'll see how much time was taken and what was the energy consumed overall. So with this, they'll realize whether it was better to offload or locally execute the task, also depending on the size of task. UAVs have a very, again, comparatively high computational power. We have assumed that they are in optimal battery range, so they'll accept all the tasks being offloaded to them, and then after executing the task and getting results, it will return the results back to mobile device. So in reinforcement learning, as I mentioned in the architecture, we have state and action that agent takes. So it is basically what agent can do to learn about the environment. And the reward is how it will realize that what was the action, it was good or bad. So we have taken a very simple state space. The distance between the mobile device and UAV is the current state. So basically, depending on the current state, mobile device will see which actions are optimal. If at a very close distance, action to offload the task to UAV is a optimal action. And at a state where the distance is very large, offloading is not a good action. So that is how it loads. Our offloading is a binary offloading. Either it will locally execute all the tasks, or either it will offload all the tasks to UAV. So the reward is something which gives trouble in reinforcement learning applications. We have kept the reward to be an linear combination, a weighted linear combination of energy and time. So this weight will adjust how much importance that we want to give to time. So here we have taken a fairly comparative weight to both of them, as uh, conserving energy and time we have considered both important. So we have done the performance evaluation of our approach. We have compared it with the basic approach of locally executing all the tasks, where all the computation is executed on mobile devices. Then offloading all the tasks to UAV, where all the tasks are executed on UAV. Then the random offloading. The agent randomly decides to offload or locally execute a task. So these were fairly simple approaches. We have also compared our approach with traditional heuristic approaches, which showed a quantitative results that it got while compared with these baseline schemes. So the parameters that we have taken in our environment, MEC server has a computational capability of 4 gigahertz, and I've not mentioned here, but the mobile devices have a computational capability of 2 gigahertz. A gymnasium is used to build RL environment, and matplotlib is used for visualization. So these two slides are representing the results. So we observed that our model takes fairly less energy while compared with the baseline schemes and heuristic approach. The execution time also drops very fairly low. We have compared two reinforcement learning approaches, namely SARSA and DQN. They showed to learn completely about the environment and took optimal decisions after exploring till 30 episodes. Learning rates are very important, crucial hyperparameters while making an environment. A fairly low learning rate will take a lot of time to converge to on optimal decisions. So what we found, the learning rate for DQN SARSA 0.01 was the most optimal learning rate. So this is the graph for reward. As we can see, the DQN and SARSA agent with blue and orange line, they're trying to maximize the reward. Here reward is negative, so the maximization takes it from minus 45,000 to minus 41,000. While the local and offloading approach have constant rewards, and the random approach learns something. So both of the agents are trying to maximize the reward, and while maximizing the reward, what they do is they minimize the energy consumed. So we can see it dropping from 12,000 to 8,000 among this on the standard units of joules. This red line represents the energy consumed when all the tasks were just offloaded. So it drops fairly low. Then same with the time taken. It tries to minimize the time consumed to execute a series of tasks. So this line compares the time taken to locally execute all the tasks. So few real world applications where this offloading is applicable or relevant, then the reinforcement learning approach will also be relevant. In disaster recovery, when UAVs are used, uh, the UAVs can do difficult tasks such as analyzing gas compositions and realizing what made the fire to start, identify objects and the situation, and communicate with IoT devices that are being used to resolve the situation. UAVs are used for surveillance in military reconnaissance, so they can enable uh, devices like uh, night vision goggles, which have less computational power, and enable them to get results for highly comprehensive computer vision tasks. So there are few limitations in our model. We have not incorporated any safety measure. UAV will accept all the tasks that are being offloaded, which is not something optimal, as it accepts tasks without verifying the legitimacy or accessing potential risks. So this could lead to system vulnerabilities, and also someone can exploit by malicious entities. Then we have just taken a single UAV environment. The better approach should be to consider a lot of UAVs for managing a larger area. Then the UAV should be able to coordinate with each other to address a large number of UAVs in highly uh, dense IoT area, and less number of UAVs in less dense area where the demand is not much to uh, execute highly like tasks in real time which have high demand or relevance. So researchers can address the limitations for single UAV environment and the security. They can implement authentication protocols, access control measures, and anomaly detection techniques, and also expand the UAV to multi-UAV environment. And again, a very better approach that comes always with reinforcement learning implementations is that we can integrate heuristic methods that can really decrease the time that RL agent takes to converge, as because RL agent learns from scratch, it will first explore about the environment, taking all the actions and learning about the optimal decision. So heuristic approaches can really improve that time. So yeah.
Excuse me, sir. Okay.
Yes.
Yes, thank you, sir. Kamran, sir, any questions for him?
Yeah, I have one question. With these limitations, do you think this method or this work applicable, physically applicable? Because with these limitations,
Yeah, yeah.
this is just work.
These are just the limitations in our work. Actually, we are working with multi-wave environment and also with the safety features.
What are the main, I can say, what was the main goal of using RL instead of other method? Because other methods have a safety measures as well. So why you have chosen RL?
So RL, the strength of RL is that it can work with highly dynamic environments. So this will nearly map to with 5G networks. A lot of IoT devices are there. So sometimes the distance is very large, and another instant the distance is low. And again, then comes the changing bandwidth. All of the factors are mobile. So RL will keep learning on the fly, and it will adapt to the most optimal decision
Thank you for
at
your
that
answer
particular
and
instant.
thank you for your presentation as well. Thank you.
Thank you. Thank you.
Yes, I want to ask, how does the performance scale with an increasing number of UAVs, users, or task complexity? Any bottlenecks identified?
Okay, so uh, the problem that we had to check it for very large number of devices, that when we took 1,000 or 10,000 mobile devices, then the time it took for training nearly went to the need of large powerful GPUs. We have tested with 1,000 devices and a single UAV. As we increase the number of UAVs and mobile devices, that is directly proportional to a highly powerful GPU to be trained first.
Okay.
Hmm.
Okay, thank you.
Thank you. Now, next, I would like to call Mo De. Ma'am, please present your paper on health feature selection for analyzing heart risk using fuzzy rough set.
Hello everyone, my name is Mo De, and today I'm going to represent our research paper Health Feature Selection for Analyzing Heart Risk using fuzzy rough set. My co-author is Professor Anirban Kundu, here from Netaji Subhash Engineering College. These are the agendas I'm going to discuss. Aim, introduction, past research, proposed framework for risk analysis, fuzzy upset-based feature selection for analyze heart disease, experimental discussions, conclusions, references. Now, our aim is to fuzzy upset-based health feature selection for identifying most important health feature to optimize the heart risk, and fuzzy upset based approximation space calculation for the lower and upper region so that it can enhance the heart risk analysis, and machine learning approach for heart risk analysis by selecting the optimal features using the fuzzy upset based data set, which will reduce the dimensionality of the data and to improve the accuracy of the heart risk analysis. Rupset theory has introduced to manage the uncertainty in data. And it is most of the problem solving technique are used as the Rupset as the computational tool, and approximation space calculation actually reducing the uncertainty of the data. But in case of the real value attribute reduction from a huge data set is a quite challenging task using the Rupset theory. And to overcome this problem, the fuzzy Rupset theory has been introduced, which will actually combine the set theory and Rupset theory, fuzzy set theory are together to deal with this problem. And fuzzy Rupset theory applied in a large data set with the feature selection technique to improve the uncertainty among the complex data set. Also, it will applying the reduct rule using the fuzzy rough set can manage to find the most important feature within a complex data set. In past research, we have studied that the cardiovascular disease is a threat in all over the world, and different classification model and machine learning based predictive frameworks are there to identify the disease. But we have found some gap during the data analysis of different model due to the noise and redundancy within the data set. And to overcome this noise and redundancy, we will introduce the feature selection using the fuzzy wrap set within the data set, real value attribute data set, and feeded that data set to the machine learning model for optimize the risk analysis. This is our proposed block diagram where the health data are stored and that health data features are selected for the classification of the problem. After that, the fuzzy wrap set is applied to select the important health feature, and that selected health feature based data set is applied to the machine learning model for further analysis, and during the comparison it will compare the selective health features with the threshold value and classify the value for the heart risk analysis and diagnose. And based on the threshold value, whatever the intensity of the risk, it will set an optimal measure for the risk. This is our algorithm that is sorry, I cannot see it. Heart risk analysis in health feature selection using fuzzy wrap set, where the initial all the health feature data set are set as an attribute set as an input, and the output is the final decision for heart risk analysis, where the input all the attribute set of health feature as an universal set. Then these important features are extracted from this universal set applying the fuzzy wrap set theory. The selected features are then sent to the machine learning model. After that, we will classify the negative and positive heart risk decision by comparing with the threshold value and analyzing the positive heart risk decision with the threshold value to identify how much risk it has, individual has. And based on that, the final decision for the optimal risk is given. Now, in the feature selection, we will use a example data set where the HD is the all attribute set of health features. And these are the selective features or the target set of age, chest pain, rest ECG, cholesterol, and the final decision for the positive cases or the negative cases are taken. Now, before dealing with, considering the selective features, we will actually find the equivalence relation, and based on that we will create a partition, and after getting the partition we will do the Cartesian product of the particular attribute set to find out the positive and negative cases. And as I have given the example table, we will take P, that is the partition for chest pain and rest ECG, because we thought that these are the most important attribute set or the health features to identify the heart risk. And according to the table 1 data, object 1, object 6 and object 7 has indiscernible with each other, and the objects 0 and 4 create the partition within the target set with the HD. And then we will proceed to calculate HD divided by IND of CP and rest ECG. And based on the attribute values, we will find the Cartesian product. And according to the Cartesian product, we will find the positive cases, the positive features which must be included for the further analysis. And here in our example case, we didn't found any negative attribute that is not impacting the health analysis. And boundary region are the case where the object are not classifying with the supplied value. In experimental discussions, we have shown the first graph is for creating the positive heart disease and negative heart disease, and indeterminate heart disease are those who are not even part of the positive or the negative, and they will need the further analysis to identify them whether they have the heart problem or not. And the next one is trying to plot the intensity of the chest pain, and based on the chest pain type, we'll consider that the level 3 is the maximized level of chest pain that may occur in the heart risk or heart disease. And based on the fuzzy rough set based data analysis by the machine learning model, it will give the accuracy, training and validation accuracy. We will compare with our proposed framework with different others framework like decision tree, logistic regression, random forest, and native Bayes. And in case of our system, we will apply binary classification using the machine learning algorithm. And during the analysis of the algorithm, we will supply the data which will already fuzzy rough set based feature selection is done. And we have found that accuracy is improved than the other one. In conclusion, we can say that we have efficient feature selection for risk analysis using the fuzzy rough set, and fuzzy rough set based approximation space is improve the accuracy of our heart risk analysis, and machine learning approach with the optimal feature selection reduce the dimensionality of data. Also, it will improve the optimal risk measurement. These are the references. Some more references. Thank you.
Thank you for your presentation. I have few questions as well. Can you tell me what was the main purpose of using fuzzy rough set based feature selection and heart risk analysis instead of any other? Second one is, did that help improve health risk prediction or not?
Yeah, am I audible?
Yeah, you are audible.
Yeah, actually, I'm applying the fuzzy rough set because, as I have said, that to remove the redundancy of the data and some unnecessary information within the data set from a complex data set, so that in the real-time attribute values or the real data values are more correctly supplied to the machine learning model. And also, I will already shown that I have achieved a bit improve result in our cases applying the fuzzy rule. Though I have not changed any algorithm in the machine learning context, only the data set is applied within using the fuzzy rough set feature selection.
Thank you. Thank you for your presentation as well.
Thank you.
Yes, I have a question. How does your fuzzy rough set method compare with other techniques like PCA, relief F, or lesser in terms of accuracy and interpretability?
Sorry.
My question is, how does your fuzzy rough set method compare with other techniques like PCA, relief F in terms of accuracy and interpretability?
No, actually, I have applied the fuzzy rough set and I am comparing with the existing tools who are applying the machine learning algorithm to detect or predict the heart disease. And as I am using the main tool is the machine learning, only the data set is sent to the machine learning model to feed or giving the prediction. The fuzzy rough set theory is applied. So fuzzy rough set is the concept where the data is being corrected and redundant data, noisy data are removed to get more focus on the particular feature which are more impacting during the analysis of the heart disease. That is the main idea behind this.
Okay. And are you planning to extend this work?
Yeah, I'm already working on this because I'm trying to focus on others machine learning algorithm, also any other tools which may have the more flexibility to make the data more precise so that we can get the best result to secure the user or the individual during their health crisis.
Okay, okay. Okay, thank you.
Thank you. Thank you to all.
Thank you, ma'am.
Shall I
Um,
stop sharing my screen?
Yes, ma'am. Now, next, I would like to call Takeshwari Sahu. Ma'am, please present your paper on streamlined deep learning techniques for weed detection in IoT-driven smart agriculture.
Okay. So, index introduction, literature review, discussion, machine learning based approach, deep learning offers several benefits, challenges of deep learning, conclusion, and references. So, first one question is arise, what is a weight detection? So, weight detection and is the process of identification unwanted plants in agriculture, well using technologies like image processing, machine learning, and deep learning. The goal is to improve crop yield while reducing uh, ha- herbicides usage. So why use software for weed detection? So traditional weed control is labor intensive and environmentally unsustainable. So integrating IoT with deep learning provide innovative solutions for accurate and efficient weed detection. So one question, so how it works? First, deep learning uses convolutional neural networks and transfer learning to classify plants in real time. And then IoT integration, sensors and cameras collected data enabling automated decision making within minimal human efforts. Then edge computing, so process data locally, reducing reliance on cloud systems and improving speed. Data augmentation, so enhance the model robustness by improving detections accuracy in various conditions. And these are some benefits of software's automations, precisions, and real times. Then literature review, titles, yes, authors and model performance and limitations. Then first design of weed detection technique using yellow models. Year was 2024's author is Sri Hari M. Ankur Chen's model yellow V7 and 8. Performance is yellow V7 SDT achieve a balance at the expenses of accuracy. Yellow V8 SDT product excellent result. Model performance. Um, uh, Model performance depends on optimization, practical deployment factors, efficiency are critical, dataset lag crop. Second is enhanced algorithm precision, a hybrid CNN SVM approach for multidimensional weight. Here was 2024's author Deepak Upadhyay, Manika Manuals, etc. And model is convolutional neural networks and accuracy 96.21. Limitation is overlap in advanced disease characteristics reduce classification accuracy for higher severity levels require diversity data for better generalizations. Then third is ensembles learning for weed detections in soybean crops. Year was 2024. Author is Velpula Shekhra Babu and Nimula Venkantram. Model use neural network accuracy 99.72, complexity of ensembles models, high computational requirements, data specific performance variability. Then object detection approach for crops and weed identification based on deep learning. Year was 2024, Ankita Thakur and Sonu Dr. Rajiv Kumar. Model use Yellow V7 and 8, accuracy 89.7 and limitations is lower accuracy compared to ensembles or hybrid approaches, dependence on robust training datasets. Then revolutionize the agriculture machine and deep learning solutions. Year was 2024. Our author is Shayad Mujtaba, Hasma Richvi, we and model जो है a Yellow V8 DesNet SV and performance with artificial neural network 1089 and accuracy 99.5 high computationals and V detection extracted, then AI based match and V detection on the edge. Year was 2024, Neem Iqbal, Wishfall Mans and model was Foster RCNN net F was Yellow V5 evaluated on corn wheat dataset FPS and MFP He reported for edge device like Nvidia, Jackson's, Xvius, and X limited to early match growth stage variability in condition not fully explored. Then evaluations of inference performance of deep learning models for real-time sweet detections. Year was 2024 conscience Vita yellow model used yellow V for accuracy 93.4% and limitation high inference time on both PC and embedded systems compared to yellow V4 and centered net. Then automatic V detection and killing proportion. Year was 2023. Renaissance Sila and Seva Tharun started. Then model use Raspberry Pi based images processing then performance direct with using reasons based algorithms, mechanical arms, spread herbicide selectively, and limitations effective only for specific environmental conditions and field reliability not addressed. Then CNN based identification of wheat in tomato farms. Year was 2023 and author is Kavya Preya, V.K. Amreen in Fatimia and Sweta M.K. Yuva R. A model used was Yellow V5, Yellow V7, and performance is Yellow V5 real-time detection and 7 is detective detection time 10 times greater than that of Yellow V5. The limited data set in automata plants. Then crop-based identification based on Fusion CNN model or deep learning. Here was 2023, G. Rajeshwar and so on. And model used Fusion CNN inception, ResNet, and accuracy 95.2 to enhance page identifications using augmented and fusion of CNN. And limitation is low performance and limited data set. Then line detection and segmentation of annual crop using hybrid methods. Year was 2023. Eric Cardos and so on. Model is the Deep Lab V3 with Kenny at technique and her transform. Performance is overall accuracy 4.1 and sensitivity to varying illumination and environmental conditions, reduced robustness in case of significant noise or overlapping lines. Then an advanced V detections using deep learning techniques, 2021, Srinivas Rao Madanlal and so on. Then model is deep learning images processing, CNN news. Performance is accuracy is 94% and limited is predefined data set not tested on diverse agricultural setups. Then supervised learning for crop weed classification. Year was 2021. Author is Haj Mehka Son and model is SCM with LBP and GLCM features. Performance is 96% and accurate, and limitation in LBP and GLCM combined have better accuracy, limited effectiveness for usually similarly crops with. Then autonomous crop row guidance using adaptive multi-role in strawberry field. Year was 2020. Author is Vignesh Raja Manapulalam, Amson and model stagnant CNN based performance is compared favorable to traditional guidance approaches and limitation is increased execution times due to additional incremental search times. Then discussions. Discussion is a machine learning systems for precise weed detection in farms, improve crop management while reducing herbicide use for better efficiencies. These are some approaches. Train and test a yellow model for accurate crop-based weed identification. And for a high means average precisions in real-time detection. There are some key areas machine learning in weed detection, exploring advanced techniques, performance analysis, evaluation accuracy of different weed species, real-world applications, and then machine learning based
Excuse me,
approaches.
ma'am.
Yeah.
I would request you to kindly conclude your presentation in the next minute because of the time constraint.
Okay, but some one slide only.
Yes, ma'am.
Okay. These are machine learning based approaches and some repetition and crop features, relative insight, and key models employed, including these are some comparison of weight detections, SVM, CNN, faster CNN, yellow 4, 7, and 9. So first of increasing yellow line very time consuming and very faster. Then deep learning offers several high accuracy and robustness. End-to-end learning, these are some challenges in deep learning, resource intensive, and the trends of these models. Then conclusions. Illuminati speeds to accuracy make it valuable tool for identify weight in real time on edge devices that have limited resources. Redirecting IoT-based agriculture systems has been the focus on research. This is particular emphasis in yellow V9. This makes it will suited to the demand of contemporary precision and transfer learning to hybrid models to improve the performance and practicality of yellow V9. This is possible. Then our references. Then thank you.
Thank you for your presentation. I have just a simple question because we didn't see your results in detail. Is it a review or you also have any you have any personal work as well? Because we just see the results of the review papers. So is it a review?
Yeah, it is a review and personal letter used in which direction.
Okay, thank
And
you.
okay.
Ma'am, any questions?
Okay, how many papers you have reviewed for this for your work?
I'm include only 14 authors,
14 from year ranges?
2024 to 2020.
2020 to 2024. Even you can search for more papers because this a lot of work, research works are being proposed these days. So you can extend your work. Anyway,
Yes,
are you planning to implement this model, something for this?
yes, I'm planning IoT devices used, drones, cameras, latex, and latex model used yellow 9.
Okay, okay, okay.
Then,
Okay, thank you. Yeah.
okay, thank you.
Now, next, I would like to call Sameer and MD. There is a co-author of this paper, Karthikeyan. Sir, are you here with us? I repeat, Karthikeyan, sir.
Hello. Hello.
Yes, sir. Hello, sir. Can you present the paper on behalf of Sameer?
Yeah.
Sure, sir. Yes, sir, you're audible to us.
Yeah. So good afternoon, everyone. Today I am pleased to present our work on developing community-centric decentralized solution for waste management at the grassroots level. So my teammate includes Bharani Kaushal, Samir, Arulmori, and myself, Karthikeyan, and our mentors are Sunil Kumar and Sauresh Kaman. So we are from Ahmedabad Vishwavidyapitham. So waste management has become a critical challenge and in developing countries like India. So in 2021 alone, India produced 71 million tons of waste, and this figure continues to rise steadily with population growth and urbanization. Unfortunately, rapid urbanization is rarely accompanied by adequate infrastructure and especially in rural and semi-urban areas. So in these communities, waste management traditionally falls to women as part of their household responsibilities. So this places them on the front line of dealing with insufficient infrastructure and low public awareness about proper waste disposal. The absence of regular
Excuse me, sir.
collection service.
I apologize for interruption, but your voice is not quite clear to us.
Can you hear me now?
Yes, sir, we can hear you, but there are some disturbances in the between.
Just, how about now?
Yes, sir, now it is clear. Thank you.
Yeah. So actually, like in these communities, like waste management traditionally falls to women as a part of their household responsibility. So This places them on the front line of dealing with insufficient infrastructure and low public awareness about proper waste disposal. So the absence of regular collections services often result in open dumping, creating environmental hazards and health risks that disproportionately affect these people. So while technology offers some potential solutions, like many implementations fail because they don't align with actual needs and context of these communities they are meant to serve. So as one size fit all approach doesn't simply work when social, cultural, economic factors vary significantly between regions. So our study has had two primary objectives. First, to thoroughly understand the specific challenges one face regarding waste management in rural communities. And second, to explore suitable technology-based solution that enhances community sustainability while addressing women-specific challenges. So for this, like our work, our research focused on Raisandra, so which is a semi-urban community in Bangalore district, Karnataka. So it is located around, located approximately 21 kilometers from Bangalore district commissioner office. So actually, like Raisandra has around 450 plus females and 500 plus males. So we concentrate our study on the older section of the village to capture its long-standing cultural practices and tradition. What stood out immediately was Rajasandra's rich cultural heritage, particularly its connection to neighboring Hoskur village, which is famous for the festival called Madrama Jatra. So the our study was conducted under Amrita Vishwavidyapidam's Live in Labs program, so which focuses on creating sustainable technological solutions for rural communities. So this program emphasizes cultural immersion. Actually, like team members actually lived in this village to gain a first hands understanding of the local culture, daily routines and challenges. We employed our research approach using like participant observation, field journals, cooperative methods. So two main methodologies guided our work was first the participatory rural appraisal. So that is called as PRA. This helped us to identify the main problems faced by villagers by encouraging participation from all community members, regardless of age or education level. By closely interacting with the community, we gain authentic insights into their perspectives and challenges. This inclusive approach was essential given our limited field study time. Second was the human-centered design, which is HCD. Once we identified key challenges, we use HCD to develop appropriate technological solutions. This methodology focuses on understanding end users' need and capabilities before designing other solutions. So our research team conducted interviews in small groups with each group including a native speaker to overcome the language barrier, which the other team member recorded the responses. So this combined approach, it ensured that our proposed solution would be both culturally and approximate and practically useful to the communities. So our PRA activities yielded several key insights. Through collaborative resource mapping with villages, we identified critical proper garbage bins and designated disposal areas. Most waste accumulated in the streets or open areas due to irregular collection, creating unsanitary conditions throughout the community. However, problem tree analysis helped us to identify and prioritize key issues, while unemployment and drainage problems were significant concerns. Uh, Waste management emerged as a major challenge with immediate consequences. Uh, the effect included waterborne infections, air and water pollution, and toxic compounds leaching into agricultural land, which directly threatening the community's primary livelihood. So the income expenditure matrix, as you could see in the screen, revealed that approximately 60% of the Raisandra's population, which relied on agriculture as their primary income source. This is significant because improper waste management directly impacts the agriculture productivity through soil and water contamination. The underlying causes of wastewater management included high population density, lack of collection points, inadequate transportation systems, and limited awareness about proper waste handling. So our HCD approach, which involved door-to-door interviews primarily with women, revealed more significant pain point. and women were disproportionately affected by waste management issues as they typically handle household waste while men are away at work and children are at school. The key problem was the mismatch between municipal garbage collection systems and household schedules. When women couldn't meet the collection trucks timing, they were focused to either keep the waste at home or dispose it improperly in nearby open spaces. Additionally, even when communal garbage bins were available, they often overflowed, causing litters to spread on streets, which further is scattered by animals, wind, or rainwater.
Excuse
From
me,
these
sir. I would kindly request you to end your presentation within the next minute.
So the proposed solution of our work is, after analyzing of findings, we determined that a centralized waste management system would be impractical given the community's limited resources and awareness. Instead, we proposed a decentralized approach that focuses on the household level. So our solution is remarkably simple, but yet it is effective. Compact garbage box is installed on a pole in front of each house at a specific height. This design allows the resident to deposit their garbage early in the morning before leaving for work, while allowing municipality personnel to collect it at their convenience. This solves the timing mismatch problem that focuses for a proper waste disposal. The box feature a cover design with latches that prevent street animals and birds from accessing the waste, thereby minimizing the littering and creating a cleaner environment. Being elevated also protect it from flooding during heavy rains. So this solution is low cost and can be implemented either by an individual household or a municipality by at a subsidized rate at a part of decentralization waste management initiative. So in conclusion, our study demonstrates the value of using participatory approaches to understand grassroots challenges and develop appropriate technological interventions. So thank you for attention. I'm happy to answer any questions about our work.
Thank you for your presentation. I have few questions. First of all, your sample was very small. That is more than 1,000 people and very small area. Do you think that if you increase the sample, it affect the results as well?
No, actually, we just focused upon the areas where it is poorly developed. Actually, that it is a big area. So we had around 7 days of field study. So for the 7 days, we were able to cover around 1,000 people. So we could able to cover around 5 to 6 kilometer of radius land area.
This problem is very common in South Asia. We already know that. You are saying that we can mount a bin in the outside of the house. It is not generally feasible. Like if there's a rain, you have to clean it as well. Do you think it is physically feasible?
Yeah, actually, under municipality guidelines, maybe they could maintain it at times, because the main problem over there was people found it very difficult, because the garbage collector people would come at times at their own times. They won't be like, say for example, they usually come at 8 o'clock. They won't be coming at 8 o'clock. So used to be differs, and people going to work are significantly affected by it. So by using our approach, maybe they could place the garbages over there, and whenever the garbage collectors, they would come and pick it up, and maybe monthly or 2 months once or 3 months once they could clean it, and they could do it. So it is actually
Is it
significantly
possible to put these things for 1 month or 2 months? Do you think?
Yeah, actually it is doable, because the waste could be collected every day, so it is doable actually.
Okay, thank you for your answers.
Yes, I want to ask, how affordable is your solution for small communities or municipalities with limited budgets? Is it financially sustainable in the long run?
Yeah, actually, like, our approach is a cost effective approach. So I feel it would be a effective one for the lower communities.
Okay, and what challenges exist in replicating your model in different regions, such as urban slums, rural village, or coastal communities?
No, I didn't get it.
I'm asking what challenges exist in replicating your model in the different regions, such as urban slums, rural villages, or coastal communities.
Actually, we are planning to introduce this to rural and semi-rural areas, and based upon people's cooperation, we feel it is highly feasible to do it.
Okay.
Okay, thank you so much.
Thank you.
Now,
Can I
next I
stop
would like
sharing
to
this?
call. Yes, sir.
Yeah, thank you.
Next, I would like to call Pranav Patil. Pranav, sir, please present your paper on AI-driven traffic forecasting and route optimization system for enhanced navigation and emergency response.
All right. Am I audible?
Yes, sir.
Okay. So, good afternoon, everyone. We are pleased to present our topic titled Survey Paper on AI-driven traffic forecasting and route optimization system for enhanced navigation and emergency response. This project is developed by Group 233 and the team members are Mihir Patil, Siddesh Patil, Prerna Matre and Pranav Patil under the guidance of Mr. Sailesh Galende. We are currently third year students pursuing computer engineering in Pimpri Chinchwad College of Engineering, Pune. Now, moving on to the introduction, the urban transportation systems face critical challenges from inaccurate vehicle localization to unpredictable traffic conditions to inefficient road quality assessments. Existing systems often fail in dense urban areas due to GPS issues and outdated forecasting models. Our solution is a comprehensive AI-driven system that integrates advanced map matching, real-time traffic forecasting using LSTM, and road quality analysis using CNNs. The aim is to optimize navigation and improve emergency response times. Moving on to the objectives, our primary objectives are develop an AI-based system that combines map matching, traffic prediction, and road anomaly detection. Utilize LSTM networks for better traffic forecasting and CNN models to detect road defects. Increase the accuracy of vehicle localization using machine learning. Provide actionable insights to municipalities for better infrastructure planning and resource allocation. Moving on to the scope of the project. The scope of the project is divided into 4 points. The real-time data collection, which involves gathering traffic and road conditions using IoT-enabled sensors such as data, accelerometers, and gyroscopes. Advanced machine learning models implementing AI algorithms like HMM for localization, LSTM for traffic prediction, and CNN or random forest for road condition detection. Urban traffic management, enhancing the navigation systems with accurate, real-time route optimization for everyday commuters and emergency vehicles. And infrastructure assessment, assisting municipal authorities with data-driven insights for road maintenance and long-term urban planning. Moving on to the methodologies and algorithms used, the project involves 4 parts. The first is the hidden Markov model or HMM, which is a probabilistic model for map matching and localization. The second is accelerometer and gyroscope data for detecting the road anomalies. The third is random forest for road condition classification and fuzzy logic for traffic and road condition analysis. Now, the HMM model is used for map matching and localization. HMM handles the noisy GPS data for accurate vehicle tracking. For example, if there are multiple road segments in front of a vehicle, then HMM simplifies and filters out the noisy GPS data and gives the most probable path for the vehicle. It is effective in urban areas with signal obstructions, example tunnels and high-rise buildings. Accelerometer and gyroscope data for road anomaly detection. The smartphone sensors can detect the potholes, bumps, and uneven surfaces as gyroscope is inbuilt in them. The sensor processes the data and jerk analysis and spectral methods. It provides real-time road condition insights for better navigation. Random forest for road condition classification uses multiple decision trees to classify road quality from the sensor data. Robust against noisy data and works well with high dimensional inputs. It provides the prediction for urban mobility applications. The fuzzy logic. It handles the uncertainty in sensor data for improved decision making. It classifies the road into different categories like good, moderate, and poor. Enhances the traffic forecasting by adapting to changing environmental conditions. Now, the results and discussions. The LSTM models show significant improvement in predicting the congestion trends. The real-time versus predicted speed comparison reveal an average deviation of 10 km per hour. The minor deviation caused by unpredictable factors like weather, road closures, and incidents. Comparing the accuracy of AI models, the CNN model shows 97% accuracy in road anomaly detection, HMM models shows 93.12% accuracy for vehicle localization, and the random forest shows 67% accuracy for road quality classifications. Moving on to the advantages, the system offers numerous benefits such as improved traffic prediction with LSTM, better localization, especially in challenging urban areas, real-time road monitoring using smartphone sensors, and faster emergency response, which optimizes routes for ambulances and fire trucks. Moving on to the applications, the systems can be applied in multiple domains, such as urban traffic control and signal optimization, then emergency services navigation apps like Google Maps or Uber, autonomous vehicle routing, infrastructure maintenance and planning, and overall smart city development. Moving on to the conclusion, to summarize, we implemented an AI system using HMM, LSTM, and CNN to improve urban mobility. The use of real-time sensor data boosted the accuracy in localization and traffic forecasting. Our model addresses key transport challenges, including GPS dropouts and inconsistent sensor data. We believe that this system has the potential to revolutionize traffic management and emergency response system in modern cities. Thank you.
Hello. Yes, what was the data size for your project, for your work?
Actually, there was different data size for different models.
Okay. So what were the size?
Like for the traffic data, we had thousands of size of data for available online. However, for road anomaly detection, we trained it in a very limited size.
Okay, so did you use feature extraction or feature selection?
We use feature extraction.
Feature extraction. So have you performed error analysis also for your project, for your work?
Yes, we performed an error analysis.
So where did you find some errors or limitations for your project?
The limitations for the project were such as comparing the uh, available models with the real-time data, as it was not possible for us to collect a large amount of data such as road condition and categorization. So that was the limitation, that we have to train the model in very limited amount of data.
Were there any situations where you found your results somewhat low or low accuracy were there?
Yes, like CNN models only showed 67% of accuracy. So
Okay.
these were the limitations.
So did you try to improve it, or you are planning to do something for that?
Yes, we are trying to increase our dataset size and performing multiple iterations on the dataset, and also trying to avoid overfitting in the data.
Okay. Thank you.
Pranav, I have a few questions as well. In the advantages, you have written a few things. If you want, you can come on the slide. Did you compare your results with other methods? Then how can you come to that results? I didn't see any comparison in your work right now. I don't have your paper on my hand as well. So can you come to the advantage slide?
Okay, should I present?
Yeah, just come to the slide of the advantages. So how can you say that these are the things? Do you compare your work with any work? Yeah, this one. Like improved traffic prediction. I didn't see any slide related to that one. Actually, we don't have any paper in your hand or in our hand. But how can you say that improved traffic prediction in a vehicle localization?
For comparison purpose, we conducted a survey or uh, the research on different papers that are readily available. For example, for LSTM, there are different methods also are readily available, and research papers are submitted on them also. So we directly compared the data that was proposed by them with our model.
Yeah, you just take that as a reference, I think so, like that. But in conclusion, you have also included these ones. That's why I'm asking. So you have take the reference and put these values, or
yes, sir. We have taken the reference from other papers and put in this value.
Thank you for your answer.
All right, thank you so much. We are now reaching the conclusions remarks. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. Thank you for the support during this 9th version and all the previous 8 versions of the conference. All the presenters would be getting their digital certificates through email within 2 working days. And all the papers have already forwarded to Springer. The publication will be live within 6 months. I would request the participants to kindly cooperate with the team of ICTIS 2025. I would like to thank our session chair, Dr. Kamran Dawood sir, for chairing the session. Thank you, sir, for your presence, and I'm sharing a token of appreciation on behalf of team and Global Knowledge Research Foundation and partners. I would request you to share any few words you may have for the participants.
Yeah, sure. First of all, I would like to extend my sincere thanks to all the presentation for sharing their insightful research, and especially to the Associate Professor Shalini Puri for her thoughtful questions. It's been a pleasure to witness such innovative work and engaging discussion. I encourage all the authors to connect during the breaks and throughout the conference and continue our work. And we will wait and look forward to welcoming you at the next ICTIC conference. I also again want to thank you on the behalf of the organization committee. Thank you everyone for joining us.
Thank you, sir. I would also like to thank Professor Shalini Puri for chairing the session. I'm sharing a token of gratitude on behalf of the team. And ma'am, I request you to share any few words you may have for the team here and the participants.
Good afternoon, everyone. So it has been a privilege to chair this intellectually rich and diverse session today. We have traversed through a fascinating range of research from AI in Parkinson prognosis and mental health assessment to innovations in emotion recognition, traffic forecasting, and sustainable solutions like decentralized waste management. I also want to thank Dr. Kamran. He has really asked so many good questions. So that was also a very appreciating part. And what stood out across all these papers is the deeply human-centric application of cutting-edge technologies. So I want to commend all the presenters for their clarity, passion, and scientific rigor. Your work not only contributes to academic knowledge, but also shows great promise for societal impact. And thank you very much for this invitation, and all the best to all the presenters. Thank you so much.
Thank you so much, ma'am. And now, as we end this session, I kindly request everyone to please turn on their cameras for a quick snapshot of this virtual conference. All right, thank you so much and have a great day ahead. Thank you, everyone.